Hi and welcome to GD3D's 3D Pathfinder YouTube channel. Today is part one of Geodesign with CityEngine. This is part of a set of tutorials that is associated with our book, mine and Dr. Paul Curitan's book, Geodesign, Urban Digital Twins and Futures. Whilst it helps if you have the book, you're not required to have the book to do the tutorial. So follow along with me. I hope you like it, hope it's useful. Let's get going. So before we start, you'll need the Geodesign CityEngine project I've created. The link to this can be found in the description below, or direct from our book website at geodesigndigitaltwins.com/tutorials. To import this project in CityEngine, go to the File menu and click Import Zipped Project into Workspace. With the open dialog box, select the project zip file you have downloaded, probably in the Downloads directory, right, and click Finish. You should now see the Geodesign project and its associated directories in the Navigator pane. Find the Geodesign with CityEngine scene file here in the Scenes directory and double-click it to open it. Once open, it should look like I have on screen. I've done some setup for you. This is an extract of our 3D city data of Lancaster here in Northern England. Please note that this tutorial is entirely fictional and I do not have any knowledge of this kind of development here. It just seems a good place to explore with CityEngine. Okay, let's proceed. Click the checkboxes to turn off visibility of all our layers in the scene pane. And while we're at it, go to the camera icon on the scene view and ensure information display and the compass are turned on. Just helps us when we're navigating to know which direction we're heading and that sort of thing. Now I've prepared some GIS data for us, so you can go to the data directory and right click on the geodesign.gdb folder and select Import. Now we're only wanting the zoning layers for now, so deselect all the layers in the dialog box except for the A_zoning layer and click Finish. You should now see it displayed in your scene view. Now have a look at the polygons here by selecting one polygon and looking at the object attributes in the Inspector pane to ensure we have some information or fields associated with our newly imported zoning data. Now I've already created a rule file for you to colour our zoning polygons. Let's have a look at it and view the code, just check it's there and it's working. We want to apply this to our polygons, so close it for now and select all our GIS polygons. Left click and drag our zoning.cga rule file, which is in the rules directory, onto our polygons, and see how just before you let go they turn orange, and when we drop the file you will see the rule has automatically joined to our associated attributes in the zoning polygons and is colouring our polygons according to the code I've given you. Not the best colour palette, but it's a start. Next, let's create a new shape layer by right clicking in the scene pane in an empty space below the layers and clicking New Shape Layer and give it the name Proposed. Then go click on the Shape Drawing Tools button on the toolbar and in the Open Tools pane on the top right hand side click on the rectangular shape creation as seen here. Enter the number 25 as in 25 meters and hit enter or click the padlock button to fix it. Then in the 3D view draw this 25 meter by 25 meters square as shown here. Don't worry, it's just going to be on the flat level adjacent to the polygons that are already there. You will see now that in the proposed layer on the left hand side in the scene view it says there's one object. Now we will create a CGA rule that can create a simple model that responds to the underlying GIS data instantly. Right click on the rules directory in our project and select New CGA Rule File and call this proposed.cga and click Finish. Now the beauty of procedural modelling in CityEngine is you don't always need to type out new code, you can reuse code from other rules. In this case we can copy and paste the code from the zoning rule I've given you. Open it up and copy the code from line 2 to line 42 as shown here, then switch to your newly created rule and paste in this code as you can see on screen. Perfect, now add the following lines to your code. I'll zoom in so you can see it. Make sure you save the code so the asterisk disappears from the file name on the editor tab. Now apply this rule to your new 25 meter by 25 meter square, and then go to the inspector and click the drop down next to the zone attribute and choose the A_zoning layer and zone attribute to connect to. Experiment a little here by moving your new 10 meter high square across the zones and look in the inspector at the zone attribute. It should change, yes? Excellent. This is what we need. Now let us add additional code to make use of this. We're going to change the colour and height of a proposed polygon depending on what zone the polygon is within. Follow the coding on screen carefully, and firstly let's make use of this function we have called _colour_zone. Basically we're passing the zone attribute to this function which will return a colour for us, and that's how it works. With this knowledge of the colouring function and how it works, we can use the same code with some modifications to change heights by passing that zone attribute again to a new function we're calling _height_zone, and it will return a number, in this case in meters initially, for the extrude function. Once completed, and make sure that there are no red error messages in your code, save it and then press generate. You can move around your proposed polygon again to see the effect of the rule. You don't need to press generate each time you do this, it's sort of updating as you go along. One last adjustment to the code is to, instead of having heights in meters, we can use those numbers to represent number of floors. To do this, we need an assumption of floor height, and then we can multiply that floor height by the returned height zone number. This will make the model naturally taller, but a little more realistic, I guess. Well, that's pretty much it for this part of the tutorial. Turn back on your layers and either move the proposed polygon on the y-axis up, or use the Align Shapes to Terrain tool here. I suggest you use Transform to keep that box extruded directly up. Turn on the View Shed layer and see how you're changing the colour, height, and see a live impact on the view sheds we've chosen. This, in a very small way, is the principle of geodesign, making informed design decisions from multiple sources and code that adapts models based on those sources. This is a very simple example, obviously, but you can use this principle on a wide variety of data sets for a range of purposes. You don't have to just change colours or extruded heights. It could be placing green roofs in particular places, or it could be adjusting heights depending on zoning codes and that sort of thing. So think about how this might be applied across a range of your potential urban projects. And think how the code could utilise your existing GIS data sets. Really interesting, really fun to play around with. Hopefully in part 2 we'll expand on this further. Wow, you've made it this far. Thanks for watching. Like and subscribe to encourage me to make more videos.